Hello, everybody out there in YouTube land. Good times for all here. Zachary Zabala, if you prefer. I have been thinking about how we would test the electric field in experimentation and in reality, and I'm not sure. Well, I know I don't have the means to do either, really, but I'm just brainstorming here and looking for ideas. What I have so far that I wanted to do, but I'm gonna have to get another Van de Graaff generator, one with a steady current that can hold the charge. But what I would do is you would have your Van de Graaff generator. I would have some kind of ruler system up here with you'd have your rod with the string on it and your mylar balloon. Now I would also have like a half compass right here that would measure the angles that the electric field would push the mylar balloon away. I would then get a piece of metal, preferably the same, you know, thickness as my Van de Graaff generator here, and with the same circumference area. With the same area. And I would check that one also, You'd have your flat one, your circular one. But the only problem is, in reality, if you have your Earth right here, the ISS is getting like this far away. And you can't even see how high we get. It's like it's still on the ground. So trying to measure that over here on a much, much smaller scale, I'm not sure how to do that. I'm thinking I would have to get a huge balloon, maybe metallic balloon, circular, spherical. I'm talking huge, and charge that, get that to be charged, and then measure that. And then maybe I could get, maybe like an inch away would be how high the balloons that we use get, or maybe even a half an inch would be enough just to measure a little bit. But if we can only get that high away, the ISS, which we all know is, well, whatever, 250 miles up, we can't get close to that at all. We can get not even a tenth of that. We have trouble getting to. Okay, so us measuring, there's other problems with the Earth as well. Where to measure it? We all know, even on the ball, there's all kinds of. Then you have your water, we'll say right here. It looks like a sphere from their pictures and all, but the ground isn't a sphere. And it's covered from water, but we would want to measure from the ground. Now, when you're on a sphere and then there's like a mountain system and it comes back down like this, the electric field here is going to be higher than it is here. And it will even be lower here at this bend than it is here. So where we measure the electric field is very important as well. Since we can't get very high as it is, we're going to need something that is parallel to sea level as much as possible and as flat as possible. So any kind of surface, well, we're actually looking like this, not like this. That's what we're looking for on the globe, is something like that. But in reality, we're looking for something like this. A very large flat plane where we can go to the center of it and then measure. That's to get our most accurate readings, since we can't get very high. Real quick, I forgot to throw this in on the original, so I'm just going to make this now. When we do this is also very important. Since we don't know what is above us, we don't know if there is a flat surface that is charged or if it is the sun that is putting off the positive charge above. I mean, and the sun is going to be, supposedly, you know, it travels from, say this is Capricorn or Cancer, equator. Then you have your North Pole here. I don't know where the sun is, you know. Does it move throughout these? We don't know. We don't know what's really going on up there. So measuring it at certain times a year, I'm thinking somewhere near the equator would be best. Because of the toroidal magnetic field that we think is kind of happening, the donut, the half donut that's going over, you know. So I don't know. Should we measure it as far north as we can get, as far south as we can get, and at the equator all at the same time? I don't know. But what time of year I think is also very important, because I think it all changes and fluxes up there just like it does down here. So I just wanted to add that part in, and back to the original video. So that's it, folks. I'm gonna try and keep this one short, but we either need a ginormous Van de Graaff with very delicate equipment, you know, specialty made for measuring this kind of stuff, because the amount we're going to be able to measure is so minute. And then in reality, when we try to measure it, we have to find the most parallel place to water for as far as we can get and jump to the center of that and send our balloons up there. It's probably out in the middle of an ocean somewhere, which really sucks. I don't do oceans. But anyway, any ideas on I plan on getting, I have a small Tesla coil now. I want to learn more about them before I assemble it. I'll do that with you guys though. And maybe getting a bigger Tesla coil and using that to charge up a large, very large surface would be possible. I'm not sure. But anyway, that's it. Testing the electric field in reality and experimentation. Is it going to be possible to do it and get any real results? So that's it. Good times for all here, signing out. As always, thanks for watching.